Hello again. The SAC64 language has now while statements. And similarly to if statements, there was some room for bytecode optimization. Let's have a look. Let's open the newest example that is bundled with the SAC64 compiler. It shows how to use the while statements. In short, the example program changes the border color and the background color for a region of the screen. The execution of the program ends when some key is pressed. The program called example05 defines first constants that are used in the program. It then defines variables that are actually specific memory locations to be read and updated. The program starts by waiting till no key is pressed. This busy loop ensures that the user has released the enter key before the actual main loop starts. The main loop in turn waits till some key is pressed. In the main loop, the interrupts are first disabled. This removes most of the flickering from the screen. Then, a busy loop waits till the raster line has returned back to the top of the screen. After that, another busy loop waits till the raster line has reached a specific row on the screen. Then the background color and the border color are changed to monochrome colors, gray and dark gray. Next, another busy loop waits till the raster line has reached a later row on the screen. After that, the background color and the border color are restored back to their default values. The last busy loop waits till the raster line has reached the bottom part of the screen. After that, the interrupts are enabled, which allows the Commodore 64 to read key presses. So, when you compile and run the program, you can see how only a region of the screen uses monochrome colors. However, because the implementation uses busy loops, there are some artifacts on the screen. The artifacts appear because the execution of the statements in busy loops are hardly ever in sync with the video update. The execution of the program ends when you press some key. As for the compilation of the while statements, there are 5 cases to be considered. The first case is the one where the expression evaluates to true or false during the compile time. If the expression evaluates to true, there is an eternal loop. If the expression evaluates to false, the entire while statement is dropped out as if it wasn't there in the first place. The second case is the one where the Boolean expression is a single Boolean variable. Then the value of the Boolean variable can be used directly in controlling the repetition of the while statement. In the next case, the Boolean expression is an inequality expression. Then the inequality comparison can be used in controlling the repetition of the while statement. In the fourth case, the expression is a generic Boolean expression. Then no optimization is applied. The expression is fully computed and the Boolean value is stored in the accumulation register. It is then used to control the repetition of the while statement. The fifth case is what is called a busy loop. Then a while statement has no body and the Boolean expression is repeatedly evaluated. This loop lasts as long as the Boolean expression evaluates to true. In this case, the code is optimized for a quick return back to the evaluation of the Boolean expression. One final consideration with the while statements has to do with the statement body. In all the previous cases, the body of the while statement was short, so the translation used direct branching for exiting the while statement. In this case, where the while statement has a long body, jumping is used instead of direct branching. So all this deduction happens in the SAC64 compiler on the background when compiling the source code. The programmer doesn't have to worry about it at all. So that is what the while statements look like. There is still much to be done, and as before, I'll keep on working with the compiler. Thanks for stopping by and see you soon!